Title of our project is 3D filament plastic wire extrusion machine with the group members Sudeep Patil, Mr. Sandeep Bhondwade, Mr. Rushikesh Suryavanshi, and Mr. Rahul Gajarmal. We have done our project under the guidance of Professor Sunil More sir. Introduction, then problem statement, aim and objective of our projects, literature review, methodology, then calculation, experimental validation, conclusion, and future scope. The construction and operation of the plastic extruder is largely based on existing design used in both industrial and hobby applications. The basic mechanism is comprised of a screw that transport raw plastic pellets from a hopper through a heating zone in a material pipe where the plastic is melted. The raw plastic pellets are gravity fed from the hopper into the screw inside the pipe. Then molten plastic is forced through a die at the end of the pipe to form a filament. The extruder plastic can be drawn from the die determine the final diameter of the filament. The die is shaped to form the extruder plastic into the desired cross section. Here's the literature review. Uh, Mr. Kishore M. Mahajan, Dr. Atul A. Patil, Professor V.H. Patil. This is a literature review about the band heaters. Band heaters are available with element of different diameters and height, designed to heat and maintain the temperature of cylindrical part. Heat transfer is usually achieved by conduction or radiation of a high uh, for a high power heaters. They are suitable for solid heating, liquid or gaseous heating. Application for band heaters are various. They can be fitted to nozzle or extruder barrels, processed plastic or today's materials such as a resin that requires high temperature or for heating conducts. They can also be used in a plastic injection molding as a process of materials requires high heating power and high temperature. This is the image showing about us the band heater. There are three types of band heater: mica band heater, ceramic band heater, and mineral band heater. This is a literature review about the machine the already existing machine. This is the literature review about the component of the 3D filament extruder machine. Uh, this is the screw we use to feed the plastic granules to the heating zone and to the nozzle. We use PID to control or set up the required temperature. Research gap for the different studies and analysis of the various paper related to defect and observation. Different researchers by paper related to extrusion process need to minimize its defect for the best extrusion product quality. Such quality problems are become inappropriate setting of operational parameters, temperature, feed, rate, RPM, as per observation taken by the researchers. By the use of the above methods, we would be improved as a predicted for the product. Problem statement. With the development of the portable filament making machine, the dependency of the manufacturing unit and other organization on third-party supplier for filament will be reduced. That is, in market, PLA filament are available easily, but ABS, PP material are made available only with the prior order. As we know, sir, in our industry, 3D printers are the new invention which is everyone use industry or college level. But the thing is, filament we have to order from other countries. We have to import filaments. Aim and objective. We need hopper for material storage, utilization of lead screw for feeding the plastic granules in forward direction, use of electric DC motor with speed controller to drive the lead screw. For heating barrel, use of electric heater with temperature controller to maintain the required temperature inside the barrel and avoid overheating of plastic. At a discharge point, nozzle is fitted, which can be replaced as per our requirement. Our we are using a nozzle of diameter 1.75. For cooling, the extruder filament utilization of forced air cooling. Objective: to design and develop a plastic filament extruder for 3D printers. The focus was specifically on creating 1.75 mm diameter filament from ABS pellets to develop a 3D printing filament making extruder that can be used by a small scale manufacturing units, companies, colleges who have portable 3D printer in-house. To perform design calculation to base the development of filament making extruder, analysis of the mechanical fabricated structure, calculation of production rate versus motor speed at time dependency available. Motivation. 3D printing is a growing technology used and is used worldwide. 3D printing requires filament to process and the cost of filament governs the cost of the 3D printing product. Filament extraction machines are usually available for industrial use, capable of creating hundreds of feet of long filament in a day. So these filaments are expensive for many end users. This work will make easily available filament extruder to small scale industries and colleges. This is the screw hopper. The screw will feed the plastic pellets to the heater and then to the nozzle. The nozzle or die where we get the required diameter filament. This is the methodology of our project study of different research paper, framing for project setup, line diagram or the model, dimensioning of frame, specification of the component for setting up conceptual model, assembling or different components, result and discussion about the error in the uh, conce- conceptual model. This is the CATIA design of our model. This is the hopper. Here is a DC motor to drive the screw. This is screw. Here it is the nozzle. A fan for the air force cooling of filament. And here we can collect the filament. It is also on DC motor drive. This is the dimension of our projects. This is wire motor for hopper, screw, work schedule. This is the proposed machine specification, technical characteristic of machine. Power consumption, screw design, single screw, screw diameter 20 mm, screw speed 100 rpm, voltage 230 volt, dimensions of machines, raw material we are using a plastic, ABS pellets. This is the machine which are available in markets, but they are cost from 18 lakh to 25 lakhs. Application polythene brought a revolution in almost all plastic industry upon discovery. Today, polythene is widely used for coating of pipeline wires, etc. It is extensively used for waterproofing application. It is used in a RO2 modeling and extrusion coating. It finds extensive application in packing industry as well. It is used for manufacturing of drip letters. It finds a widespread application in manufacturing of pipes, bulk, and rigid packing, HM films, and much more. Low-grade polythene is used for making carry bags. Toy industry also use polythene extensively. This is from my side, sir. Thank you, sir.
Hello, sir. Can we start?